Hello friends, I am Dr. Sudhansh Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University. And today's session is about software evaluation, and this is the first session in the sequence of the lectures. In our previous lectures, we had already discussed about the various hardware components, hardware architectures, wherein we had discussed about the input-output unit, apart from this central processing unit and the construction of the central processing unit, and largely the control unit, arithmetical logical unit, memory unit, and what are the functionalities of the hardware. But we need to understand that hardware and software goes hand in hand. They are having the relation likewise body and soul. The body relates to the hardware part, whereas soul relates to your software. Without software, there is no use of hardware. Without hardware, there is no use of software. So the machines are actually working in the binary languages, that is 0 and 1, and this is nothing but like 0 and 1. They are the voltage signals, that is 0 volt or 5 volt. So 5 volt is generally considered as 1 and 0 volt is generally considered as 0. Although there are some noise reasons, likewise 0 to 1.5 volt is considered as 0 and 3.5 volt to 5 volt is considered as 1. So we need to map these voltage signals into your binary formats, and these binary formats are being transformed into the languages which are being understood by the human beings. So that means this transformation of the languages, apart from this, that how the softwares are developed, how the softwares are evolved, how the softwares make the hardwares to control. Likewise, we are having different types of softwares. We are having linkers, loaders, parsers, assemblers, compilers, interpreters, translators. So they are not evolved within a day. They are evolved, they took a lot of time, and there are different aspects which are related to their evolution. And in this session, we are going to cover the evolution of the softwares, and we understand what are the different aspects which are considered when the softwares are evolved. So to begin with, what is in fact a software? Software is nothing but a sequence of execution of programming instructions which are given to the hardware in a definite order. And we need to understand that nowadays we are doing programming in our English language, but we just discussed that the hardwares are working in the voltage signals, or 0 or 1, that is the binary format. So we need to map the English context sentences into the binary format, into the voltage signals. So how the mapping is being done, that is being done with the help of the software. And softwares and hardwares goes hand in and hand out. So we need to give the software programmer develops the code, and the whatever software is being developed is giving instructions to the hardware, and accordingly the hardware works. That means when we are using any application software, we are giving a print command and the printer is actually working. We are going to save the file into the pen drive, then the file got stored into your pen drive, and n number of hardware operations are being performed, and but behind that the respective softwares, be it respective drivers or other application softwares concerned, are actually working. So the evolution of the software involves various aspects. Likewise, we are having the aspects of, say, architectures, software paradigms, programming languages, licensing, and we are having open license softwares, we are having proprietary softwares. So far as the language paradigm is concerned, we are having a procedural languages, object-oriented languages. So far as the paradigms are concerned, non-structured programming, structured programming or modular programming, object-oriented programming, component-based programming, service models based programming are different paradigms which are related to the evolution of the softwares. Apart from this, so far as the architecture is concerned, we are having the mainframes, we are having file server based models architectures, we are having client server architecture, internet based architecture, and cloud architecture. So these are some of the aspects. That means the software evaluation is based on various aspects, be it your programming language, be it your paradigms, be it your architecture or licensing. In this session, we are going to discuss about the architectural aspect, paradigm aspect, and the programming language aspect. Apart from this, licensing and all other aspects will be discussed in our subsequent sessions for software evolution. So far as the mainframes are concerned, the mainframes, the input-output terminals are actually working as the dummy terminals, and the actual processing is actually centralized. So whatever connected terminals are there, they are just providing the data, and the data is being passed on to the central server, wherein all processing is done, and the processed data is being passed on to the respective nodes. So that means the connected nodes were not intelligent enough. So as there was evolution of microcontrollers, personal computers, and apart from this, the development of LAN models, the intelligence was imparted into the nodes, as a result of which the mainframe models, the mainframe architecture was improved to the file server based architecture. But there was some limitation to the file server based architecture, and the drawback was that as the number of users are being increasing, the performance of the file server based architecture got deteriorated. Because of this drawback, it was proposed that we need to improvise the architecture, and a new architecture was proposed, and that architecture was your client server based architecture. And the client server based architecture has got different tiers. We are having 2-tier client server architecture, 3-tier client server architecture, and n-tier client server architecture. Over here you might be seeing that in your this 2-tier client server architecture, we are having a server database and the client interface, and client is sending a request to the server, as a result of which the server is responding to the client. So there are 2 nodes, client and server. This type of architecture is known as 2-tier client server architecture. In the 3-tier client server architecture, we are having an application server which is being sandwiched in between the database server and the client, that is the user interface, and the whatever request is being made by the client is passed on to the database server through the application server. So we can increase the number of application servers in between the database server and the client server, and accordingly the number of tiers in the client server architecture is increasing. This client server architecture was actually responsible for the development of the internet based architecture. Parallelly, one need to understand that in a client server architecture, it is not necessary that client and server both rely on the separate machine. It might be possible that both client and server may be lying onto the same machine. So servers are the programs which are actually responding to the requests made by the clients, and clients are the programs which are requesting for the resources from the servers. So we can have the server and the client onto the same machine also. So the internet based architecture is actually a architecture wherein the client make request to the web server, and the client the software which is running on the client side is nothing but a web browser. The web browser connects to the web server, and this web server passes on the information to the application server, and based on the request received by the application server, the requested information is being derived from the database server, and it is passed on to the client, that in the same manner, that is from the database server to the application server to the web server and to the client node. So that means what is the advantage of this internet based architecture, that we need not to tailor the applications. They are because internet is available onto the onto all types of machines which are running different type of operating systems, which are having different type of hardware configurations. So that means the internet based applications need to be platform independent. So because of this platform independence, this architectural format gives wider visibility and wider access to the applications, content, and the data available. So apart from this, nowadays we are having the cloud computing. which is again supported by the internet-based architecture, but all the things, all the services, be it software, be it platform, be it interface, be it any service, they are being available on the pay-per-use model. So whatever you can expand or you can contract your requirements as per your needs of your software development, and accordingly you can avail the client services. And this cloud models are available in private cloud models are there, public models are there. We are having hybrid models, and we are not going into those details, but you can arrange for softwares, you can arrange for hardwares, you can arrange for platform interfaces, and any type of usage, any type of component you want to use, you can always use with the help of the cloud architecture, wherein you need to just pay for the use. So nowadays the softwares are heavily relying on to the cloud computing part. Now, apart from this, so far as the aspect of the software paradigm is concerned, software design paradigm is concerned, we are having different phases of the evolution of the softwares, and these phases are firstly involving the non-structured design paradigm, and then we are having the structured and modular design paradigm. Apart from this, they are followed by object oriented design paradigm, component based design paradigm, and service oriented paradigm. Now we are going to discuss about the non-structured design paradigm. In non-structured design paradigm, the programming is actually done in a sequential manner. The program, likewise over here in the screenshot, you might be seeing that there are numbering given to the program lines of codes, and there is a statement, go to statement. That means this go to statement makes the program to switch over from line number 1 to line number 10. And at line number 10 we are again having the code go to 2. That means it makes you to loop. So many a times when we are doing the programming, it is required to perform looping constructs, and in order to perform looping constructs in non-structured programming, we are using the go to statements. So the non-structured programming is actually consists of the sequentially ordered statements, and that means each statement is given one after another, and the lines of codes are heavily numbered, and the flow of, or that means switching of the codes from one line to another line is done with the help of the go to statement. So there is no concept of the procedures or functions. The design paradigm is actually meant for the reusability of the code. That means we want that we should write once and we should reuse it at any point of time. We should not rewrite the code again and again once a component is being built up, but this feature is not being available in the non-structured design paradigm. So in order to introduce the this procedural aspects, functional aspect, wherein we write the code at one point of time and make it use at subsequent requirement points. So this feature is available in structured and the modular design paradigm, wherein we can develop a procedure, we can develop a function, and we can call the procedure or function as and when required. Likewise over here in the diagram, in the flow chart diagram, we are having, say we are having step 1, and then we are having a condition, test condition, and going to path 1 and path 2. And path 1 and path 2, after executing step 2 and step 4, there is the requirements of procedure. And apart from when we are moving from part 2, step 3 is also requiring the procedure. So procedure is written at one point of time, and this procedure is being recalled at path 1 and also at part 2. That means by step 3 as well as step 4. So this is the fundamental requirement of the design paradigm, that how to design a software so that we need not to write the code again and again. Once the code is written, it can be reused. And this reusability aspect is being imparted into the software with the help of the procedures and function. And this facility of reusability is not available in the non-structured programming design paradigm, and whereas it is available into the structured and the modular design paradigm. The procedures and the modules are actually compartmentalizing the code into a single unit, and this single unit is actually can be called into the programming as and when required. So this understanding of reusability of the code was further extended into the object-oriented programming. The object-oriented programming is quite closer to the nature. Likewise, over here we are having the concepts of class and object. We are having n number of concepts, likewise encapsulation, inheritance, and polymorphism. We are going to discuss these concepts, but in order to briefly understand that how object-oriented programming is closer to the nature, say we are having a class chair, then we can derive n number of types of chairs, like a rocking chair or office chair, or say any other normal use chair. So these all are of the category of chairs. They are having the same features as if they are having 4 legs and back and a sitting place, but they are for the different purpose. So we are having a class and we can derive n number of objects from this class having the same type of features. So this type of facility is imparted with the help of the object-oriented programming. So object is, you can say that is an instance of a class. So class is something which is having some data and which is having some methods, and those data and methods are being extracted by the object and implemented with the help of the inheritance. You can derive n number of type of objects, derived classes. So likewise over here we are having 2 classes. The school is there and student is there. The school class is having some properties and methods, and student class is also having some properties and methods. And student can be of different type. They might be full-time student, they might be part-time student, or whatever. And apart from this, school can be private school or public school, or open schooling might also be there. So that means we can derive different type of instances for the schools as well as for the students. And in the so you might be thinking that if there was a procedure which can be recalled, then how the class is different from the procedure, so in the or the function part. So we are having the concept of structures in the structured programming paradigm, but in the object-oriented paradigm we are having the concept of classes. But the data and the functions and the methods are quite safer. We can control the accessibility to the data and the functions and the methods in the object-oriented paradigm. And the encapsulation is one of the most important feature of the object-oriented paradigm, wherein we can hide the data and the properties and the methods from the from their unauthorized access. So on the lines of the object-oriented paradigm, wherein we are imparting the reusability of the code with the help of the classes, and we can reuse the code by imparting the concept of the inheritance and polymorphism. The philosophy was extended onto the component-based paradigm, wherein the concept of plug and play. That means this type of paradigm was extended from the object-oriented paradigm, but it gives more abstract view of the software system than the object-oriented method. That means we develop the independently deployable black boxes, which are called components, and that these components communicate through contracts. And they are actually used in the plug and play manner. That means we can call these components into our programming part as and when required. Likewise, maybe into an e-commerce website, we might be calling, for an example, a shopping cart website application may use off-the-shelf credit card authorization component. So the off-the-shelf means we are having the components which are kept off the shelf, and as and when they are required, they are being just called into our program, and they can be deployed as a part of the software. So this same concept of the component was extended, and a new paradigm was proposed, that is your service-oriented paradigm. And this service-oriented paradigm, as we had already discussed, is widely exercised in the field of the cloud computing, whereas all the things are being provided as a software as a service, SaaS model, platform as a service, PaaS, interface as a service, IaaS services. So all the things are being provided to the clients in the form of the service. So the services are readily available. You can ask for the services as per your requirement, and accordingly you are supposed to pay for the your usage. So these component models and all these are quite interlinked. Now one need to understand that as if we moved from the mainframe architecture to your file-based server architecture, then client-server architecture, then internet-based architecture, and then your cloud-based architecture, and the programming paradigm is also being shifted from your non-structured programming paradigm to structured and module-based programming paradigm, and thereafter we are having object-oriented paradigm and your component-based paradigm and service paradigm. We need to understand because of the evolution of software on the basis of architecture and on the basis of the paradigm, there should be the evolution of the software on the basis of the programming languages. So on the basis of the programming languages, the software is being evolved, and we came up with two type of programming languages styles. Like one is the procedural programming languages, and other is the object-oriented programming. So far as the procedural programming languages are concerned, the famous example is your C programming language, and your Fortran programming is a procedural programming language, wherein you are having the procedures, you are sequentially executing the program. So what is the fundamental definition of the program is? The program is sequence of execution of instructions, and COBOL is one of the language which is being evolved from the procedural language, and it is being transformed to the object-oriented part also. And the procedural languages, as if the names itself suggest that they follow the procedure. That means they start their execution right from the beginning and goes up to the end. Likewise, in a C program, the program execution starts from the main. So always, wherever the procedure is that one has to go to the main part, and then the execution will start, and till the entire main module is being completed. So that means the programming languages are linear in fashion, and they follow the procedure, and C and Fortran are the famous example of the procedural languages. But so far as the object-oriented languages are concerned, you can reuse the components in a very effective manner by using the concept of the classes, objects, and using the features of inheritance, your polymorphism, and many more things are there. So C++, C#, Java, all are the examples of the object-oriented languages. And so because we are into the nowadays the trend is of the object-oriented language, so we need to have some of the understanding of the basic concept of the terms related to the object-oriented paradigm, and they are encapsulation, wherein we are going to protect the data and the procedures, the methods from the unauthorized access, and this is being provided by the mechanism of the encapsulation. So far as the mechanism of inheritance is concerned, we are having the concept of the parent class and the derived class. The derived class is the class which owes the features and the properties of the parent class, but it has got its own features. Likewise, we had cited the example that chair might be a parent class, but office chair, your wheelchair, all are examples of your derived class. They are the chairs, they are having the features of the chair, but they are having their own features. So that's why by using the concept of inheritance, we can derive a variety of the class. So there is a lot of flexibility in object-oriented paradigm. So far as polymorphism is concerned, we are imparting the strength of making the same operators working in a different environment in a different way. Likewise, we may have the addition operation. So if the addition operation is applied onto the mathematical component, they will work as sum. But if the plus operation is applied onto the strings, then it will work as a part of the concatenation. And if we say apply for on some colors, then they will work for the mixing of the colors. So there are some of the important terms. Likewise, over here we are having class, and which is a set of functions that work together to accomplish a task. And object is nothing but an instance of a class which owes the features of the class. Apart from this, we had each and every class has got some methods which refers to the functions that are encased in a class, and these functions are being facilitated by some parameters, and which are the variables which are being passed on to the function to perform some instructions. So these are some of the important terms, and in this session we had covered up to the programming language aspect of the evolution of the softwares. In the subsequent session, we will be discussing about the licensing part of the software evolution, and apart from this, we are also going to discuss about the different type of softwares which evolved across the time. Likewise, linkers, loaders, parsers, assemblers, interpreters, and all many more. And thank you all for this session. और भाई बढ़िया।